Picture this. It's the year 800 CE, and you're standing in the steaming jungles of the Yucatan Peninsula. The air is thick with humidity and the sound of thousands of workers hauling massive limestone blocks up wooden ramps. What you're witnessing isn't just construction. It's one of the most ambitious engineering projects in human history. The Maya are about to pull off something that would make modern contractors weep with envy. You might think building a pyramid is just about stacking rocks really, really high. Wrong. What the Maya accomplished was like trying to build the Empire State Building using nothing but rope, wooden tools, and human muscle power. Except their version lasted over 1,000 years and still makes archaeologists scratch their heads, wondering how they pulled it off. Here's something that will blow your mind. The pyramid you're watching rise from the jungle floor isn't even the first one. The Maya are literally wrapping a brand new pyramid around an older temple that's already standing there. It's like putting a bigger house around your current house, except your house weighs several million pounds, and you're doing it without cranes, bulldozers, or even the wheel for transportation. The numbers behind this operation are staggering. We're talking about moving roughly 200,000 tons of limestone. That's equivalent to about 40,000 elephants' worth of stone. Every single block had to be quarried by hand, shaped with stone tools, and hauled across miles of jungle terrain. The logistics alone would give modern project managers nightmares. But here's where it gets really interesting. And I want you to stick around because what I'm about to show you will change how you think about ancient civilizations forever. Make sure to hit that subscribe button, smash the like button, and drop a comment, letting me know what surprised you most about Maya engineering. Trust me, by the end of this video, you'll have at least 3 jaw-dropping facts to share at your next dinner party. The Maya didn't just wake up one morning and decide to build a pyramid. This was a carefully orchestrated operation that required master planning, specialized work crews, and a level of organization that would impress any modern corporation. We're talking about coordinating thousands of workers across multiple job sites, managing supply chains that stretch for miles, and maintaining quality control standards that ensured these structures would survive centuries of hurricanes, earthquakes, and jungle growth. Let's start at the very beginning of this incredible process, the quarry. The limestone quarries of the Yucatan weren't like the massive open pits you might imagine today. Instead, Maya quarrymen worked in smaller, more targeted operations that required an intimate understanding of how stone behaves under stress. These weren't random guys with hammers. They were specialists who could read limestone like a book. The quarrying process itself was pure genius, wrapped in backbreaking labor. First, the crews would identify the best stone by looking for specific color patterns and testing the rock's density. They developed techniques that modern geologists still respect, tapping stones with hammers to listen for the telltale sounds that indicated internal flaws or perfect consistency. Once they found their target stone, the real work began. The Maya had discovered something that would make any modern contractor jealous. Wooden wedges and water could split massive limestone blocks with surgical precision. Here's how this seemingly impossible technique worked. Workers would drill a series of holes along the desired break line using copper and stone tools. The holes had to be perfectly aligned and exactly the right depth. Too shallow and the stone wouldn't split. Too deep and you'd waste precious time and energy. Next came the wooden wedges, usually made from hardwood that had been carefully selected and shaped. These wedges were driven into the holes with stone hammers, creating tremendous pressure along the fault line. But here's the brilliant part. They'd soak the wedges with water. As the wood absorbed moisture, it expanded with enough force to crack solid limestone. It was like having a hydraulic jack made entirely from forest materials. The sound of a successful split was reportedly heard throughout the quarry, a sharp crack that meant another building block was ready for the pyramid. Workers described it as the stone giving up its secrets, surrendering to human ingenuity. One successful quarrying operation could produce enough stone to keep the construction crews busy for weeks. But getting clean breaks was only half the challenge. Each block then needed to be rough-shaped using hammerstones, carefully selected rocks that were hard enough to chip limestone, but not so hard they'd shatter on impact. The skill required for this work was extraordinary. Master stoneworkers could shape a block to within inches of its final dimensions, using nothing but their eyes, their experience, and perfectly controlled hammer blows. The waste from this shaping process wasn't actually waste at all. Every chip, every fragment of limestone was carefully collected and sorted. The larger pieces became rubble fill for the pyramid's interior. Medium-sized chunks were perfect for making lime mortar. Even the smallest chips and dust had a purpose. They'd be mixed into the final stucco coatings that would cover the finished structure. Meanwhile, other crews were operating the lime kilns, massive fire pits that transformed limestone into the binding agent that would hold the entire pyramid together. Operating these kilns required its own specialized knowledge. The temperature had to be just right, hot enough to chemically transform the limestone, but not so hot that it would ruin the batch. Too cool, and you'd end up with expensive charcoal and useless rock. Too hot, and the lime would become brittle and weak. The fuel requirements for these kilns were staggering. Each batch required enormous quantities of wood, which meant dedicated logging crews working in the surrounding forests. They became experts at selecting the right types of wood for different burning characteristics. Some woods burned hot and fast, perfect for getting the kiln started. Others provided steady, consistent heat for the long burning process that could take days to complete. The finished lime had to be slaked with water in carefully controlled conditions. This process generated tremendous heat and toxic fumes, requiring workers to approach with wet cloths over their faces. The timing was critical. Too much water too fast would ruin the batch, but waiting too long would let the lime harden into useless chunks. But producing perfect building materials was pointless if you couldn't get them to the construction site. This is where the Maya transport system becomes absolutely mind-blowing. Remember, they didn't have wheels, horses, or oxen. Everything had to be moved by human power alone. The solution was a combination of engineering brilliance and brute force organization. Maya engineers built packed causeways, raised roadways made from crushed limestone and clay that could handle the weight of massive stone blocks. These weren't just paths through the jungle. They were engineered highways designed to specific grades and widths. The stones themselves moved on a system of wooden rollers and sledges that required perfect coordination between teams of haulers. Picture trying to move a 2-ton block of stone across miles of jungle terrain, using nothing but logs, ropes, and human muscle. The logistics were staggering. Teams had to work in perfect synchronization, constantly moving the rollers from back to front as the sledge advanced. The really clever part was how they handled the inevitable obstacles. Stream crossings required temporary bridges strong enough to support multi-ton loads. Hills meant building switchback routes that kept the grade manageable for human haulers. Soft ground meant laying down additional stone foundations to prevent the transport system from sinking into the jungle floor. Communication along these transport routes was handled by relay systems of drum signals and horn calls. Each team knew exactly when to pull, when to rest, and when to reposition their equipment. A single miscommunication could result in a runaway stone block that would destroy equipment and potentially kill workers. The most impressive transport challenge came when stones reached the pyramid itself. Now they had to be moved up increasingly steep ramps to reach the higher levels of the structure. The Maya solved this with a system of shallow earthen ramps built at carefully calculated angles, typically between 1.4 and 1.5 ratios. These ramps wrapped around the growing pyramid like a spiral staircase for giants. But here's where the Maya engineering really shines. They discovered that adding water or clay slipped to the ramp surfaces dramatically reduced friction. It was like creating an ancient slip and slide for multi-ton stones. Teams of haulers could move blocks up these ramps using a combination of ropes, wooden cribbing for support, and perfectly timed pulling sequences. The ramps themselves required constant maintenance. Traffic from thousands of workers and hundreds of stone blocks would wear down the surfaces, create ruts, and occasionally cause dangerous collapses. Dedicated crews worked around the clock to keep the ramps safe and functional, essentially rebuilding sections every few days. Managing traffic on these ramps was like directing a construction site crossed with a highway system. Empty sledges coming down had to coordinate with loaded sledges going up. Worker crews needed clear paths for their daily commutes. Supply lines for food, water, and tools had to flow continuously without interfering with stone transport. The Maya developed a sophisticated system of traffic control that included designated passing areas, scheduled transport windows, and priority systems for different types of cargo. Emergency procedures were in place for everything from equipment failures to worker injuries to sudden weather changes that could make the ramps too slippery or dangerous to use. What makes this entire operation even more remarkable is that it was all coordinated without written work orders, computer scheduling, or modern communication systems. The Maya relied on a combination of verbal traditions, visual signals, and perfectly trained work crews who knew their jobs so well they could adapt to changing conditions without missing a beat. At the heart of this massive construction site, master masons were performing what can only be described as ancient precision surgery on stone. These weren't just guys who knew how to stack rocks. They were artists, engineers, and mathematicians rolled into one, creating structures that would make modern architects weep with admiration. The platform construction started with something that sounds simple, but was incredibly complex: laying a rubble core. Think of it like building the world's most important sandwich, where every ingredient had to be perfect, or the whole thing would collapse and probably kill a few hundred people in the process. The core wasn't just random chunks of stone thrown together. Each piece was carefully selected, positioned, and locked in place with lime mortar that had to cure to exactly the right consistency. Here's where it gets really wild. The Maya masons could eyeball measurements that modern builders need laser levels to achieve. They used string lines and plumb bobs, basically weighted strings, to ensure every surface maintained the perfect batter, which is the technical term for the slight inward slope that keeps massive stone walls from falling over. Getting this angle wrong meant your pyramid would either look like it was melting or actually collapse under its own weight. The veneer stones that covered this rubble core were works of art in themselves. Each block had to be dressed, carefully shaped and smoothed to fit perfectly with its neighbours. We're talking about tolerances so tight that you couldn't slip a knife blade between finished stones. The masons achieved this using nothing but stone tools and an understanding of geometry that would make your high school math teacher proud. But here's something that will blow your mind. These master craftsmen were working while hanging off the sides of a growing pyramid, with nothing but rope harnesses keeping them from becoming very flat pancakes on the jungle floor below. Try doing precision stonework while dangling 100 feet in the air with only braided plant fibers keeping you alive. That's basically what these guys did every single day. The grand staircase presented its own set of mind-bending challenges. This wasn't just a way to get to the top. It was a precisely calculated astronomical instrument. The Maya aligned these stairs to solar markers, creating a giant stone calendar that could track the movement of the sun, moon, and planets with accuracy that wouldn't be matched in Europe for another 500 years. Each step had to be exactly the right height, depth, and angle. Too steep, and the priests conducting ceremonies would tumble down like a religious avalanche. Too shallow, and the astronomical alignments would be thrown off, which in Maya culture was basically the equivalent of breaking the universe. The balustrades, those decorative side rails, weren't just pretty additions either. They served as additional calculation points for astronomical observations and had to be positioned with mathematical precision. The small shrine chamber at the summit was perhaps the most challenging part of the entire construction. This tiny room had to support massive timber lintels while maintaining perfect structural integrity. The lintels themselves were engineering marvels. huge wooden beams that had to be hauled up the pyramid and precisely positioned without modern lifting equipment. One wrong move, and you'd have a several-ton piece of timber crashing down through everything you'd just spent months building. Getting these lintels into position required a coordination effort that would impress modern crane operators. Teams of workers using rope and pulley systems had to lift, rotate, and perfectly position each beam, while other crews guided it into place with long poles. The margin for error was basically zero. These beams had to fit into specially prepared stone sockets, with tolerances measured in fractions of inches. Once the structural work was complete, the finishing crews took over, and this is where Maya craftsmanship reached levels that still make modern builders shake their heads in disbelief. The stucco application process involved multiple coats of lime plaster, each one requiring different mixing ratios, application techniques, and curing times. The first coat was rough, designed to fill gaps and create a solid base. The second coat was smoother, beginning to hide the individual stones beneath. But the final coats, sometimes 3 or 4 additional layers, were applied with techniques that turned limestone dust into surfaces as smooth as marble. The secret was in the burnishing process, where workers used special stones to polish each coat to a hard, glossy sheen that would reflect sunlight like a mirror. The pigments used for painting these surfaces came from all over the Maya world. Hematite reds were ground from iron ore deposits. Carbon blacks came from carefully controlled fires that produced pure soot. But the most spectacular colour was Maya blue, a brilliant turquoise created by combining indigo dye with a special clay called palygorskite. This colour was so stable and vibrant that examples still glow with colour after more than 1,000 years. Creating these pigments was almost as complex as building the pyramid itself. The indigo had to be extracted from specific plants at exactly the right time of year. The palygorskite clay came from distant deposits and had to be processed through heating and grinding cycles that took weeks to complete. When combined, these materials created a chemical bond that made Maya blue virtually indestructible, more durable than many modern paints. The application of these pigments required its own specialized knowledge. Different colors had different properties. Some needed multiple thin coats, others could be applied in single thick layers. The timing was critical because the lime plaster continued curing for weeks after application, and applying paint too early or too late could result in colors that would fade or flake off within months. But perhaps the most fascinating aspect of the entire construction process was something that happened throughout the building: the ritual deposits. At carefully calculated moments during construction, work would stop while priests performed ceremonies and placed offerings in special caches within the pyramid structure. These weren't random religious ceremonies. They were precisely timed events that coordinated the spiritual and physical construction of the pyramid. Foundation deposits were placed before major structural elements were built. Stair deposits were positioned at specific steps that corresponded to astronomical calculations. Each cache contained carefully selected items: shells representing water and the underworld, jade symbolizing life and rebirth, obsidian blades sharp enough to cut flesh from bone, and copal incense that would carry prayers to the gods. The obsidian blades were particularly impressive. These weren't crude stone knives, but precision instruments sharper than modern surgical scalpels. Creating them required master craftsmen who could nap volcanic glass into tools with edges only a few molecules thick. Each blade was a work of art that took hours to create and could be ruined by a single misplaced blow. The copal incense came from specific trees that had to be tapped at precise times of year. The resin was then processed through heating and aging cycles that could take months. When burned, it produced aromatic smoke that was believed to carry human prayers directly to the gods. The quality of copal was so important that some caches contained pieces that had been aged for years, specifically for pyramid dedications. These ritual deposits weren't just spiritual practices. They were integral to the construction timeline. The Maya believed that building a pyramid without proper spiritual preparation would result in structural failure, natural disasters, or divine punishment. Work schedules were coordinated around ritual calendars that determined when specific ceremonies could be performed. The entire construction process operated on multiple calendars simultaneously. The solar calendar determined when certain astronomical alignments were possible. The sacred calendar governed ritual activities and determined auspicious dates for major construction milestones. Even the lunar calendar played a role, as some activities were believed to be more successful during specific moon phases. This meant that construction crews couldn't just work at maximum speed. They had to coordinate their efforts with cosmic timing that might require stopping work for days or weeks while waiting for the right astronomical conditions. Project managers had to balance labor efficiency with religious requirements, weather patterns with sacred obligations. The result was a construction schedule that looked nothing like modern building projects. Instead of steady progress toward a deadline, Maya pyramid construction followed a rhythm that accelerated and decelerated based on factors that modern engineers would consider completely irrelevant to the actual building process. But this wasn't just about religious timing. It was about creating something that would function as both a building and a massive ceremonial calendar carved in stone. The Maya weren't just constructing a pyramid. They were building a machine that would track time itself with precision that wouldn't be matched anywhere else in the world for centuries. The work gangs that made all this possible were organized with military precision, and each group had specialized skills that took years to master. The quarry crews weren't just strong guys with hammers, they were geological specialists who could read limestone formations like a book. They knew which stones would split cleanly and which would crumble into useless chunks. A master quarryman could look at a rock face and predict exactly how much usable stone it would yield, down to the individual blocks. These quarry teams worked in groups of about 20 men, with each crew capable of producing roughly 50 dressed stones per day under ideal conditions. But here's the catch. Ideal conditions were about as rare as honest politicians in ancient Mesoamerica. Rain would shut down operations for days because wet limestone became unpredictable and dangerous to work with. Excessive heat made the stone tools brittle and prone to shattering. Even the phase of the moon affected work schedules, since Maya calendar calculations determined which days were auspicious for different types of labor. The ramp crews faced their own unique challenges that would make modern construction workers demand hazard pay and therapy sessions. These teams had to maintain the massive earthen ramps that spiraled up the growing pyramid. And this wasn't just a matter of keeping the pathways clear. Every day, hundreds of multi-ton stone blocks were dragged up these ramps by teams of haulers, creating wear patterns that could turn a smooth roadway into a death trap overnight. Ramp maintenance required constant attention to drainage, surface texture, and structural integrity. Too much moisture and the ramps became slippery slides that could send stones and workers tumbling down in deadly avalanches. Too dry and the surfaces became dusty, making it impossible for hauling teams to maintain their footing during the coordinated pulls that moved massive blocks up steep inclines. The traffic control on these ramps was like managing a highway system designed by someone who'd never seen a wheel. Empty sledges coming down had to coordinate with loaded ones going up, all while making room for supply crews carrying food, water, and tools to workers throughout the pyramid. The Maya developed hand signals, drum codes, and horn calls that could communicate complex traffic instructions across the noise and chaos of active construction. But the real heroes of this operation were the masonry crews, and these guys were operating at a level of precision that would make modern stonemasons weep with envy. Each crew consisted of about 15 specialists, master masons who could cut stone to tolerances measured in fractions of inches, apprentices who mixed mortar to exact consistency standards, and support workers who positioned blocks using leverage systems that multiplied human strength through pure mechanical advantage. The mortar mixing alone required skills that took years to master. The lime had to be aged for specific periods. Too fresh and it would burn the stones. Too old and it wouldn't bond properly. The sand had to be sorted by grain size and cleaned of organic materials that could cause structural failures decades later. Water ratios varied based on temperature, humidity, and even the time of day when the mortar would be applied. Getting the mixture right was like following a recipe where the ingredients changed based on weather conditions, and getting it wrong meant watching months of work crumble into expensive rubble. Master masons could tell the quality of mortar by its color, smell, and the sound it made when stirred. Some claimed they could predict how long a batch would remain workable just by watching how it moved in the mixing bowl. The kiln crews operated what were essentially ancient chemical factories that transformed limestone into the binding agents that held the entire pyramid together. These weren't simple fire pits. They were sophisticated furnaces that required precise temperature control and fuel management. Each kiln could process about 2 tons of limestone per firing cycle, but the process took anywhere from 3 to 5 days, depending on weather conditions and fuel quality. Managing kiln temperatures without modern thermometers required skills that bordered on supernatural. Experienced kiln operators could judge internal temperatures by the color of flames, the smell of smoke, and even the sound the fire made as it consumed different types of wood. Too cool, and you'd end up with expensive charcoal and useless rock. Too hot, and the lime would become brittle and weak, creating mortar that would fail under the immense weight of pyramid stones. The fuel requirements were staggering. Each firing consumed roughly 10 tons of carefully selected hardwood. This meant dedicated logging crews working in surrounding forests, cutting specific species of trees that burned with different characteristics. Some woods provided quick, intense heat for starting the kilns. Others burned slow and steady for the long heating cycles that transformed limestone into workable lime. But here's where the Maya system gets really impressive. All these specialized work gangs had to coordinate their efforts across time periods that spanned years, not weeks. The pyramid construction wasn't a sprint. It was a marathon that required sustained effort from multiple generations of workers. Master craftsmen would train apprentices who would eventually take over their roles, creating continuity of skills and techniques that ensured consistent quality throughout the entire project. The stucco application process alone could take months to complete properly, and this is where Maya patience and perfectionism really shine through. Each coat had to cure for specific time periods before the next layer could be applied. The first rough coat needed at least 2 weeks to reach proper hardness. The intermediate coats required a week each, but only if weather conditions were perfect. Too much humidity and the curing process slowed to a crawl. Too little moisture and the stucco would crack as it dried. The final finishing coats were applied in multiple thin layers, each one burnished to a mirror-like polish before the next was added. This burnishing process used specially selected stones that had been shaped into polishing tools. The technique required circular motions applied with consistent pressure, and the timing was critical. Too early and you damaged the underlying coat. Too late, and the surface wouldn't achieve the glossy finish that made Maya pyramids gleam like jewels in the jungle sunlight. Between each burnishing session, the surface had to be inspected for flaws, cracks, or inconsistencies that could ruin the final appearance. Master plasterers could spot imperfections that were invisible to untrained eyes, and they had techniques for repairing minor flaws without starting entire sections over. But major problems meant scraping off layers of work and beginning again, a prospect that could add weeks to already lengthy finishing schedules. The periodic maintenance required to keep these structures looking perfect was almost as complex as the original construction. Maya pyramids weren't built and forgotten. They required constant attention to prevent the jungle from reclaiming them and to maintain the brilliant white surfaces that made them visible from miles away. Whitewashing crews worked on rotating schedules that covered different sections of the pyramid throughout the year. The lime-based paints used for these maintenance coats had to be mixed fresh because they couldn't be stored for extended periods. Weather windows for repainting were limited to dry seasons when humidity levels wouldn't interfere with paint adhesion and curing. Stair repairs were particularly challenging because these surfaces experienced constant wear from ceremonial traffic and weather exposure. Individual steps had to be recut to maintain proper dimensions, and worn areas needed to be built up with fresh stone and mortar. The astronomical alignments meant that even minor repairs had to maintain exact measurements. A step that was off by even a few inches could throw off solar calculations that priests relied on for ceremonial timing. But the most demanding aspect of pyramid maintenance was the color restoration process. Those brilliant reds, blacks, and Maya blues weren't just decorative. They were integral to the structure's function as a ceremonial calendar and astronomical instrument. Faded or damaged pigments had to be carefully removed and replaced using the same techniques and materials as the original application. The Maya blue restoration was particularly complex because creating new batches of this unique pigment required coordinating supply chains that stretched across the Maya world. The indigo dye came from specific regions where the right plants grew in soil conditions that produced the most vibrant colors. The Palygorskite clay came from distant quarries that were often controlled by different Maya city-states, requiring diplomatic negotiations just to obtain raw materials. Processing these materials into usable pigments took months of careful preparation. The indigo had to be harvested at exactly the right stage of plant maturity, then processed through fermentation cycles that could take weeks to complete. The clay required heating, grinding, and purification steps that eliminated impurities that could cause color variations or adhesion problems. When properly prepared and applied, Maya blue was virtually indestructible, more durable than many modern synthetic pigments. But the process was so complex and expensive that it was reserved for the most important ceremonial structures and the most skilled artists. A single mistake in the preparation or application process could ruin materials that had taken months to prepare and cost more than most Maya families would see in a lifetime. All of this maintenance work had to be scheduled around the ritual calendar that governed when different types of work could be performed. Major restoration projects required ceremonial permissions and had to be timed to coordinate with astronomical events that determined auspicious dates for beginning important activities. Construction crews couldn't just show up and start working. They had to wait for cosmic approval that might be weeks or months away. This created a unique rhythm of work that was unlike any modern construction project. Instead of steady progress toward completion, Maya pyramid construction and maintenance followed cycles that accelerated during favorable periods and virtually stopped during times when the calendar prohibited major construction activities. Project timelines were measured not just in months or years, but in ritual cycles that could span decades. The result was a construction system that created structures of incredible durability and precision, but at a pace that would drive modern project managers to early retirement. Maya pyramids were built to last not just centuries but millennia, and the construction methods reflected this long-term perspective in every carefully planned detail. The dedication ceremonies that marked completion phases were spectacles that would make modern opening ceremonies look like quiet dinner parties. These weren't just ribbon-cutting events. They were cosmic performances that synchronized human achievement with celestial movements in ways that required mathematical calculations so complex they'd give modern astronomers headaches. Picture this. After months or years of construction, the Maya had to time the pyramid's dedication to coincide with specific astronomical events. We're talking about equinoxes where shadows would fall at precise angles, creating serpent-like illusions that slithered down the pyramid steps. Getting this timing wrong wasn't just embarrassing, it was considered a cosmic disaster that could bring divine punishment on the entire city. The shadow calculations alone required understanding of solar geometry that wouldn't be matched in Europe for another 800 years. Maya astronomers had to account for the Earth's axial tilt, the pyramid's exact latitude, and the specific angle of each step to create these shadow performances. 1 degree off in any direction, and your multi-year construction project would produce shadow effects that looked more like abstract art than divine serpents. But here's where it gets really mind-bending. The Maya didn't just build these pyramids to create cool shadow shows once or twice a year. They engineered them as massive three-dimensional calendars that tracked multiple astronomical cycles simultaneously. The main staircase might align with the equinox, while side features tracked the movements of Venus, the moon's phases, and even the complex cycles of eclipses that occurred decades apart. Creating these alignments required surveying techniques that make modern GPS systems look almost primitive in their precision requirements. Maya engineers had to account for the curvature of the Earth, atmospheric refraction that bent light rays, and seasonal variations in the sun's apparent position. They did all this using nothing but carefully positioned stakes, plumb lines, and observation techniques passed down through generations of master builders. The really incredible part is that these astronomical alignments had to be built into the structure from the very beginning of construction. You couldn't just add them at the end like decorative features. Every stone, every angle, every measurement had to contribute to the final astronomical performance. This meant that construction crews were essentially building a giant stone computer that would calculate celestial events centuries into the future. The equinox displays themselves were choreographed performances that involved not just the pyramid, but entire plazas filled with precisely positioned observers. Different viewing locations revealed different aspects of the shadow play. And the Maya mapped out these viewing zones with the same precision they used for the pyramid construction itself. Priests and nobles had designated spots that provided optimal views, while commoners watched from areas that revealed less dramatic but still impressive shadow effects. The timing of these ceremonies wasn't just about astronomical accuracy, it was about demonstrating the divine connection between Maya rulers and cosmic forces. A pyramid that perfectly predicted eclipses or tracked Venus cycles proved that the king who built it had supernatural powers. Miss the timing by even a day, and your political credibility could crumble faster than poorly mixed mortar in a hurricane. But the most challenging aspect of these dedication ceremonies was coordinating them with construction schedules that were already complicated by weather, material supplies, and ritual requirements. Imagine trying to complete a massive construction project by a specific date that's determined by astronomical calculations made years in advance, using only human labor and hand tools, while dealing with seasonal rains that could shut down work for months. The pressure on construction crews during the final phases must have been incredible. Missing the dedication deadline wasn't just a scheduling problem. It was a cosmic failure that could result in everything from political upheaval to divine retribution. Work crews probably pulled the ancient equivalent of all-nighters, laboring by torchlight to apply final coats of stucco or position the last ceremonial elements. The mathematical precision required for these projects reveals something remarkable about Maya civilization that most people never realize. These weren't primitive people randomly stacking stones. They were sophisticated mathematicians and astronomers who understood concepts that European scholars wouldn't discover for centuries. They had developed the concept of zero independently, created number systems that could handle calculations involving millions, and tracked astronomical cycles with accuracy that rivals modern computer predictions. The pyramid construction process also reveals the incredible organizational capabilities of Maya society. Coordinating thousands of workers across multiple specialized tasks, managing supply chains that stretched across vast distances, and maintaining quality control standards that ensured structural integrity for over a millennium. These accomplishments required administrative systems that were more complex than many modern corporations. Think about the logistics involved in just feeding the construction crews. A pyramid project employing 2,000 workers would consume roughly 4,000 pounds of food every single day. Multiply that by construction periods that could last several years, and you're looking at food requirements that would challenge modern supply chains. The Maya had to develop agricultural systems, storage techniques, and distribution networks that could support these massive projects without causing famine in surrounding communities. The economic impact of pyramid construction rippled throughout Maya society in ways that modern economists are still trying to understand. These projects required specialists in dozens of different crafts, creating demand for everything from rope makers to pigment producers to astronomical calculators. Entire communities probably reorganized their economic activities around pyramid construction schedules, with farmers timing their harvests to coincide with peak labor demands, and craftsmen adjusting their production cycles to supply construction materials. But perhaps the most impressive aspect of Maya pyramid construction was how they managed to innovate and improve their techniques across generations while maintaining the astronomical precision that made these structures work as cosmic calculators. Each new pyramid incorporated lessons learned from previous projects, refining construction methods and astronomical alignments in ways that pushed the boundaries of what was possible with their available technology. The legacy of these construction techniques extended far beyond the pyramids themselves. The organizational methods, mathematical concepts, and engineering solutions developed for pyramid construction influenced Maya architecture for centuries. Techniques pioneered on major pyramid projects were adapted for everything from residential construction to urban planning, creating a technological foundation that supported one of the most sophisticated civilizations in the ancient Americas. Modern archaeologists are still discovering new aspects of Maya construction techniques that challenge our understanding of what was possible without modern technology. Recent excavations have revealed construction details that suggest the Maya understood principles of structural engineering that weren't formally recognized in Western architecture until the Industrial Age. They developed concrete formulations that have remained intact for over 1,000 years, created drainage systems that still function perfectly today, and designed foundations that have survived earthquakes that would level modern buildings. The precision of Maya astronomical alignments continues to amaze researchers who study these structures with modern instruments. Computer-assisted surveys have confirmed that pyramid alignments are accurate to within fractions of degrees, achieving precision that would be challenging even with contemporary surveying equipment. This level of accuracy required not just mathematical knowledge, but practical engineering skills that allowed ancient builders to translate theoretical calculations into physical structures with tolerances measured in inches across structures hundreds of feet tall. Perhaps most remarkably, the Maya achieved all this while working within cultural and religious constraints that would seem impossible to modern project managers. Construction schedules were dictated by ritual calendars that might prohibit work for weeks at a time. Material choices were influenced by spiritual significance as much as structural requirements. Even the workforce had to be organized according to social and religious hierarchies that determined who could perform different types of labor. The result was a construction system that created some of the most impressive architectural achievements in human history, built by people who understood that true engineering excellence required balancing technical precision with cosmic harmony. Every Maya pyramid stands as proof that human ingenuity, properly organized and sufficiently motivated, can accomplish things that seem impossible even by today's standards. So there you have it. The Maya didn't just build pyramids, they built time machines, carved from limestone and painted with pigments that still glow after 1,000 years. What started as moving 200,000 tons of stone, block by block, became something that would make modern engineers question everything they know about what's possible with human hands and brilliant minds. The numbers tell the whole story. Quarry crews producing 50 stones daily when the stars aligned properly. Ramp teams rebuilding entire sections every few days while coordinating traffic that would make highway engineers weep. Masonry crews achieving tolerances that modern laser levels struggle to match. Kiln operators managing temperatures by listening to fire sounds. Stucco teams waiting weeks between coats for perfect curing conditions. But here's what really gets me about this whole operation. Every single decision was made twice. Once for engineering requirements and once for cosmic timing. The Maya built these pyramids to last forever, And they succeeded by treating construction schedules like religious ceremonies and treating religious ceremonies like precision engineering projects. The next time you're complaining about a delayed construction project or wondering why some building isn't finished on time, remember that the Maya coordinated thousands of workers across multiple job sites while calculating astronomical events decades in advance, using nothing but rope, stone tools, and mathematical concepts that wouldn't reach Europe for centuries. Those gleaming white pyramids rising from the jungle weren't just buildings, they were proof that human beings could create permanent monuments to both engineering excellence and cosmic understanding. The Maya figured out how to build eternity using nothing but human ingenuity, endless patience, and the kind of organizational skills that would make Fortune 500 companies jealous. And they're still standing today, still tracking the sun and stars with computer-like precision, still challenging everything we think we know about what ancient civilizations could accomplish. That's the real magic of Maya pyramid construction. It wasn't just about moving stones, it was about moving time itself.